Assalamu alaikum. Today we are going to learn about capacitors and supercapacitors. First of all, let's see what are capacitors. Basically, capacitor is a device which is used to store charge, which can store charge, you can say. A capacitor is a device capable of storing energy in the form of electric charge. Um, as compared to battery, capacitor can store less amounts of energy, but it is more useful than battery. Then capacitor's construction. A capacitor is consist of two metal plates which are separated by insulating material called dielectric. The plates are conductive and they are usually made of aluminium, tantalum or other metals, while dielectric can be made out of any kind of insulating material such as paper, glass, ceramic, anything that can obstruct the flow of current. The capacitance of capacitor measured in farad, it is directly proportional surface area of two plates as well as permittivity of dielectric. While the smaller distance between the plates, the greater will be the capacitance. Here you can see the metal plates are set aside, which may be of aluminium, tantalum, silver or other metal, while dielectric may be of paper, glass, ceramic or other insulating materials. Okay, capacitance of capacitor is represented by C and it is equal to epsilon A over D into farad. Here C is capacitance of capacitor, epsilon is absolute permittivity of dielectric, A is overlapping of surface area, D is the distance between plates and F is the farad, which is the unit of capacitance. Smaller will be the distance between plates, greater will be the capacitance. Then see the working of capacitor. We can note that metal typically has an equal amount of positive and negatively charged particles, which means it is electrically neutral. If we connect a power source of battery to metal plate of capacitor, current will try to flow, or the electron from plate connected to positive lead of battery will start moving to the plate connected to negative lead of the battery. However, because of the dielectric between the plates, the electron won't be able to pass through the capacitor, so they will start accumulating on the plate. After a certain number of electronics accumulated on the plate, the battery will have insufficient energy to push any new electronics to enter the plate because of the repulsion of those electronics which are already there. At this point, the capacitor is actually fully charged. The first plate has developed a negative charge and the second plate has developed the equal net positive charge, creating an dielectric field with an attractive force between them which hold the charge of capacitor. Here you can see the both poles are with positive and negative charge and the movement of negative charge from one pole to another. Then moving toward the supercapacitor. What are supercapacitor? A supercapacitor is a specially designed capacitor which have a very large capacitance. Supercapacitors combine the properties of capacitors and batteries into one device. Then see the characteristics. Charge time. Supercapacitor have charge time and discharge time completed to those of ordinary capacitor. It is possible to achieve high charge and discharge current due to their low internal resistance. Batteries usually take up to several hours to reach a fully charged state. A good example of a cell phone battery, while supercapacitance can be brought to the same charge state in less than 2 minutes. Then cycle life and safety. Supercapacitor batteries are safer than ordinary batteries when mistreated. While batteries are known to explode due to excessive or high heating when short circuited, Supercapacitors do not heat as such due to their low internal resistance. Shortly fully charged supercapacitor will cause a quick release of stored energy, which can cause electric arcing and might cause damage to device. But unlike batteries, the generated heat is not a concern. Supercapacitors can be charged and discharged million of times and have virtually unlimited cycle, while batteries only have cycle life of 500 times and higher. Then move toward the construction. The construction of supercapacitor is similar to the construction of electrolytic capacitor in that they consist of two foil electrodes, an electrolyte, and a foil separator. The separator is sandwiched between the electrodes and foil is rolled and folded into shape, usually cylindrical or rectangular shape. This folded form is placed in a housing impregnated with electrolyte and hermetically sealed. The electrolyte used in the construction of supercapacitors as well as the electrodes are different from those used in ordinary electrolytic capacitors in order to store electric charge. A supercapacitor uses porous material as separators in order to store ions in those pores and atomic level. The most commonly used material in modern supercapacitor is activated charcoal. The fact that carbon is not good insulator result in maximum operating voltage limited to under 3 volt. Activated charcoal is not the perfect material for another reason. The charge carriers are comparable in size to the pores in the material, and some of them cannot fit into the smaller pores, resulting in a reduced storage capacity. Here you can see the construction of supercapacitor. There are polarized electrodes. There is a separator, electrolyte which contain ions, positive and negative ions. The collectors also have oppositely charged ions like uh, collectors are also present, and electric double layer is present with positive and negative ions. Then moves toward the advantages and drawbacks of supercapacitors. There are some advantages of supercapacitor, uh, like high power density value, quick charge and discharge, do not blow up in short connection, stops energy flow when fully charged, extremely small internal, long shelf life and extended lifetime, no gas emission and environmentally safe, environmentally friendly. Okay, and then let's see the drawbacks. Need a balancing circuit for series connection. Number two, terminal voltage and SOC is directly proportional. Number three, price and market delivery challenges. Number four, power supplies for very short duration. And number five, highest dielectric absorption. So that's all about the capacitors and super capacitor. Thank you so much.